Okay, let's go on page 74 when we are done. We are applying the exponential growth and decay stuff that we did early on when we did exponentials, so you might want to turn your ISN to, I think it's page 62-ish, wherever those formulas were, because they're not on here, but you're going to need to know them, okay? So grab your ISNs, turn to page, let's see if it's on 62. I'll tell you, yeah. 62, and then I think maybe, what's on 63? I think it might be both pages. Yeah, so 62 and 63 are what we're going to need to look at today. Okay. All right, so exponential growth and decay applications. These questions look very much like what we did before, but they're not exactly the same. So this says Mark started a new blog to write about his travels. In its initial week, the blog had 800 readers. From this point on, the number of readers each week increased by 25%. Use an exponential growth model, something right there, growth model, to find the week in which the number of visitors reaches 10,000 people. Okay, so first we have to decide, we know it's exponential growth. Is it continuous? No. Is it compounded? No. So it's just the plain old exponential increase, right? So that would be f of t equals what? A times 1 plus r to the t power, right? That's the formula we have to use. Now, it doesn't say write and use a growth model. If it did, then I would need an f of t equals with some numbers in it, but it just says use it. So, I mean, you need to know what that is. You probably should write that down. And then what am I looking for? Which part of that function? Yeah, which week? So I'm looking for time, right? Which means I need to know everything else in there that's a variable, because if I don't, then I can't solve it. So what is f of t? 10,000, because that's what, you know, the total would be. So we get 10,000 equals, what would a be? 800 times, so then 1 plus r. So the rate is 25%, so this would be 1.25, yes, to the t power. So t is our only variable. We got to solve for t. So what would be the first thing we would do? Divide by 800. So I can divide both sides by 800. If it comes out to be a decent, nice-looking decimal, then I can use it. If not, I need to leave it as a fraction. So what is it as a decimal? 12.5, okay? So I get 12.5, so that's fine. 12.5 equals 1.25 to the t power. What would I need to do next? Log of both sides. I got to get t out of the exponent. So I'm going to take the natural log of 12.5. That equals the natural log of 1.25 to the t power, right? So then that t gets to come out front now, right? So I get the natural log of 12.5 equals t times the natural log of 1.25. Then what do I do? Divide. So natural log of 12.5 divided by the natural log of 1.25 equals t. Say what? You did this before? I believe so in Algebra 2, yeah. You should have anyway. So you should get that t equals 11.319. But guess what? Just getting a number, yeah, it's exactly what you did in Algebra 2, and, you know, any monkey can push buttons on a calculator, but you have to be able to interpret that number and actually answer the question that's being asked. So it says, find the week in which the number of visitors reaches 10,000 people. Okay? So in what week is it going to reach 10,000 people? In the 12th week. Over 11 weeks have passed, right? When over 11 weeks have passed, what week are we in? We're in week 12. Does that make sense? So because of the way the question is asked, we would say in the number of visitors will reach 10,000 people during the 12th week. Make sense? So you got to come up with a number, and then you also got to make sure you can use that number to actually answer that question in a coherent fashion. Okay, we good with that? What questions do we have? And of course, the wording can be a little bit different, but you still got to say the same thing. We good? All right, so let's look at number 2. 2 says, a new stock entered the stock market in January of 2012 at 72 cents per share. 4 years later, the price per share was $3.85. Using a continuous exponential growth model, find the growth rate. Continuous exponential growth model. So that means that would be A equals what? PERT. P times E to the RT. And I'm looking for the growth rate. So I'm looking for R. Means I need to know everything else or I can't solve the problem, right? So what would A be here? 3.85. And what would P be? 0.72. Good. Then we have E to the, well, the rate's what I'm looking for. Time is 4. So I'm going to put 4R because it would bother me if I put R times 4, but it's fine if you do. It just seems like, I don't know, I just can't write that. All right, so then I'm going to take 3.85 and divide by 0.72. If it's a decent decimal, then I'll use it. If not, I'll use the fraction. Did you get a decent decimal? Yeah, that's a lot of decimals. So instead, we could just leave it as the fraction. What's the fraction? It's not really worse. I mean, it's a matter of opinion, but there are times where you absolutely can't use the decimal, but we'll use the fraction here, the 4R. All right, so then what would my next step be? Natural log. So I'm going to take the natural log of both sides. So I get the natural log of 385 over 72 equals the natural log of e to the 4r power. So natural log of 385 over 72. 4r gets to come out in front. And what's the natural log of e? 1. So it's really nice when we can use the natural log and it's just 1, so I don't need to do that, anything else with that. Then my rate is the natural log of 385 over 72 all over 4. And then you can type that into your calculator. And you can do the fraction and a fraction thing. So did we get 0.41914? Yes? All right. And then, so it just says find the growth rate. So I can say the growth rate of the stock was what? 41.914%. That is a lot. It's the kind of stock you want to buy into, right? Okay, what questions do we have? We good? All right, so let's do a half-life problem here. It says a certain medicine has a half-life of 5 hours. If a patient is given 500 milligrams at noon, at what time will they have 100 milligrams remaining in their bloodstream? So is this continuous? No. Is it compounded? No. So it's really just f of t equals a times 1 plus r to the t power, right? I am looking for time, so I got to know a, r, and f of t, right? So what is f of t? Oh, wait, I did that wrong. What's wrong with my equation? It should be minus, yeah. This is decay because it's half-life. I should have put minus. No, I can't get an eraser. It just occurred to me that I wrote the wrong thing. There you go. Because it's decay, right? All right, so what is f of t then? No, 100, okay. So 100 equals, what's a? 500, good. What's the rate? 0.5. So 1 minus 0.5 is 0.5 to the t power. Is it to the t power, though? Does it happen every hour? No, it happens every 5 hours. So what do I need to do with t? Divided by 5. Good. Everybody okay with that? It's half-life. A lot of times you have to take that into account unless it actually happens every day. All right, so then I would divide by 500. Does that become a decent decimal? Yes, 0.2. So 0.2 equals 0.5 to the t over 5 power. So now that now I can take the log of both sides to get my exponent out. So the natural log of 0.2 equals the natural log of 0.5 to the t divided by 5 power. So natural log of 0.2 equals t divided by 5 times the natural log of 0.5. Then I would divide by the natural log. So natural log of 0.2 divided by the natural log of 0.5 equals t over 5. Then what would I do? Multiply. Good. So t is equal to 5 times natural log of 0.2 over natural log of 0.5. So this number that you get, what does that represent? How many hours? This is how many hours. Is that what this is asking me? No. It asks me at what time, right? So what time did all this start? At noon. So it's been over 11 hours since noon, so it's nice that it started at noon because that means it's 11 something, right? And, but 11 what? Do I say 11.6 o'clock? That doesn't make any sense, right? So how do I figure out what it is? Okay, so you'd put it over, so you're trying to do proportion, so that's good. So you would put like the point, so this is one option, 0.609 blah, blah, blah over 100, over 1, right? Because that's out of like a whole hour, right? That much out of a whole hour equals x over 60. So really in the end, aren't you just multiplying this by 60? So in your calculator, if you got that number, all you have to do is subtract 11 to get the whole number out, and then do times 60. Okay, does that make sense? So you just always subtract the whole number, even if it's like inches and feet, right? You can take the number of whatever you have, subtract off the whole number, and multiply it by 12 if you're doing inches and feet. So you just subtract 11 from the number that's in your calculator. You'll get this whole decimal. You multiply that by 60, and then we can say that they will have 100 milligrams remaining in their system at 11 something p.m. Okay, so we need to talk about that something, because don't you get 36 point something, 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 right? So do we round up or do we round down, or what happens? Well, if it's going to continually decrease, then if I use 1137, isn't it possible that it's actually less than 100 milligrams at that time? But if I use 1136, then while the clock says 1136, are they going to have 100 milligrams left in their bloodstream? Yes, so we're going to go with 1136. It takes a little bit of reasoning to go, through that sometimes. All right, what questions do we have? All right, flip it over. Let's look at number 5. It says a small lake is stocked with certain species of fish. The fish population is modeled by the equation below, where P is the number of fish in thousands and T is the number of years since the lake was stocked. How many years will it take the fish population to reach 6,000 fish? All right, so this is one of those, what's the word? Logistic growth. The logistic growth models where it's going to level off at some point. So pretty much the whole thing's given to you except for P and T. You have two unknowns in there, right? Which one are we looking for? T. So I need to be able to substitute something in for P. So what would P be? 6,000? Six? Why 6? Very good. So P is the number of fish in thousands. So if you put in 6,000, you have the right idea, but that's the wrong number, and it's going to get you something weird. Okay, very good. So P is 6. That's equal to 8 over 1 plus 3 times e to the negative 0.7 t power. All right, so what would we do next here? Can these two things just switch places? They actually can, and that's the first thing somebody told me last period, but for those of you that are not sure, because what's going to happen is you're going to multiply both sides by the denominator, and then you have to divide by 6, so they really just end up switching places. I'm going to go through the steps so that I don't completely lose anybody, but I would be okay with you it's fine just to switch them. So if I do the actual steps, though, I would multiply both sides by the denominator to get rid of the fractions, so it's going to 6 times 1 plus 3 times e to the negative 0.7 t power equals 8. And then I divide by 6, so I get 1 plus 3 times e to the negative 0.7 t power equals 8 over 6, which is 4/3. Okay, so see how they switch places, except then I reduced also. Now here, definitely no decimal for that 4/3, because that's a repeating number. What would I do next? I am not ready for a log, not even close. Subtract 1 from both sides. So I get 3 times e to the negative 0.7 t power. What's 4/3 minus 1? 1/3. There you go. What's the next thing I would do? Divide by 3. So we get e to the negative 0.7 t power equals what? Not 1. 1/9. Dividing by 3 is the same as multiplying by 1/3. Now I can take the natural log of both sides. So the natural log of e to the negative 0.7 t power equals a natural log of 1/9. What do we know about the natural log of e? It's 1. So when this comes out front, we get negative 0.7 t times 1, basically, so I don't need that, the natural log of 1/9. So then t is equal to natural log of 1/9 divided by negative 0.7. Oops, that's it. All right, so can I have part of a year? Yes, I can. This question is asked differently than the week question. The week question said within what week is this happening? This doesn't say in what year. It says how many years. So we can't have part of a year, and we would have 3.139 years. So it will take 3.139 years for the fish population to reach 6,000 fish. And if it asks for it in, years and months, we could convert. All we'd have to do is subtract 3 and multiply by 12, right? And we'd know how many months. All right, we good? Yes, okay. All right, so number 6. If $500 is deposited into a retirement account that pays an annual interest rate of 4% compounded quarterly, how long will it take the account to reach a balance of $1,200 if there are no other deposits or withdrawals? So compounded quarterly, we have our compounded interest. A is equal to P times 1 plus what? R over N to the NT power. And so it says, how long will it take? So I'm looking for T, which means I have to know A, P, R, and N. Do I know A? Yes, I want to know when it reaches $1,200, right? That's equal to, what was the principal? 500. And then 1 plus, what's the rate? 4%, so 0.04 divided by what? 4 to the 4t power. Everybody okay with all that? We are looking for t. So now I can divide, what's 1200 divided by 500? 2.4. So I get 2.4 equals, well, 1 plus, so 0.04 divided by 4 is 0.01. I add that to 1, and I'm going to get 1.01 to the 4t power. Now I can take the log of both sides, so natural log of 2.4 equals the natural log of 1.01 to the 4t power. So natural log of 2.4 equals the natural log, oops, sorry, I should have got that up front, 4t times the natural log of 1.01. I want to get t by itself, so what can I divide by? Natural log of 1.01. Can I go ahead and move the 4 with that? Like I can leave the t there, and I can multiply by 4 times the natural log of 101 all at one time. Like I don't have to, I can do it in pieces, but yes, you can take it with you there. So natural log of 2.4 divided by 4 times the natural log of 1.01 equals t. Okay, so then type all that in. Okay, so in this case, we got 21.99597. I mean, that's really super close to what? 22. So in this case, like it will take, we could say about 22 years. And anytime you're going to round up, round down, interpret the answer or whatever, the actual number that was in your calculator needs to be there. Even if you round it to 3 decimal places there, it's fine. But then we're going to say it's about 22 years just because of the nature of the problem. Okay? Make sense? We good? All right. So let's get number 7 set up, and then I'll let you work it. So it says Dave deposited $500 into a savings account. After 15 years, the account balance had tripled with no other deposits or withdrawals. Assuming the interest compounds continuously, find the interest rate. So compound continuously means I use A equals what? PERT, P times E to the RT power. I'm looking for R, so I need to know everything else. What's A? 1,500. Because it tripled. That's equal to the initial, which is 500 times E. I'm looking for the rate. The time is 15, so 15 times R. All right, you go ahead and work on finishing that up while I hand out the assignment. Okay, do you all agree with that? 7.324. Yes? Awesome. All right, so you can go ahead and get that put in.